It's a beautiful day in Venice, and Lisa's going for a stroll with her dad across a narrow footbridge. Nothing seems out of the ordinary, but Lisa doesn't know what lies ahead. Since Lisa's looking down at her phone, she is oblivious to her surroundings. Kids these days. 10 seconds and some dramatic irony later, she trips on a loose stone, falling backwards off the bridge and sending her phone flying in the other direction. Lisa's mum freezes in place, shocked, unable to move.
Luckily for Lisa, however, there is still hope. At the moment she tripped, a gondola was passing under the bridge at high speed. In fact, 80% the speed of light. Now normally, when the boat is stationary, it is the exact same length as the bridge. But now that the boat is travelling at speed, we have a problem. According to Einstein's special relativity, an object moving extremely quickly will physically contract in the direction it is moving. Have a moment looking into Einstein's eyes to take that in. Yes, moving quickly enough, the pencil will physically become shorter. Got it? Okay, well this phenomenon is now widely accepted and proven, so now you double check the title of this video and ask yourself, where's that paradox I was promised?
Well, here goes nothing. The complexity comes in when we consider Lisa's fall in different reference frames. You can think of these as points of view. The first reference frame we are going to take is that of Lisa's father, who is still standing on the bridge, horrified and motionless. From his point of view, he and the bridge are stationary and the boat is moving under them. Therefore, from this point of view, the gondola will contract, making it shorter than the bridge, meaning Lisa and her phone will be taking an unexpected swim. On the other hand, from the point of view of the boat driver, he and the boat are stationary, while the bridge flies past him. This means that for him, the bridge would contract, and the boat would stay its normal length, ultimately making the boat longer than the bridge. In this situation, both Lisa and her phone would land safely on the velvet cushions of the Italian gondola. Only one result is possible. So is the boat shorter or longer than the bridge? And what happens to Lisa?
Unfortunately for Lisa, her future is looking rather wet. To explain why, we are going to have to turn to another theory. It turns out that contraction is not the only bizarre and classically counterintuitive thing that happens when objects move at significant proportion of the speed of light. We also observe something else. When moving at such a speed, all old understanding of simultaneous events breaks down. This theory is fundamental to Einstein's relativity and fittingly called the relativity of simultaneity. It states that events that are simultaneous in one reference frame are not necessarily simultaneous in another reference frame. As seen here, travelling at different speeds relative to an observer affects the order in which events take place. For those interested, this is limited to events that are not causally connected. That is, to independent events, like say a young lady and her phone falling into a canal.
And now back to Lisa, who is about to find out the result of this experiment for herself. As seen before, from her father's point of view, the boat is shorter than the bridge, and Lisa falls into the water. From the boat driver's point of view, however, the boat is longer. Because of the relativity of simultaneity, what he sees is actually different to what Lisa's father sees. He sees the phone fall into the water first, and once the boat has moved forward, Lisa fall in second. As the relativity of simultaneity predicts, just because both Lisa and her phone fall in at the same time for her father, doesn't mean they fall in at the same time for the gondolier.
The high speed of the gondolier shows that yes, the boat was longer, but also that the timing of the two events became different, so that the same result was achieved in different ways by different observers.
As the experiment and the title of this video clearly demonstrate, two things that happened at the same time didn't necessarily happen when they did.